section in chapter 4 is now solving equations with fractions. And you guys all did really well with the equation part of our last exam. So remember, equations is you want to get the variable by its side by doing the opposite operation, right? So if you have a number on the same side as a variable, you move it over doing the opposite. So if it's added, you would subtract it over. If it's subtracted, you add it, and vice versa, okay? So that's what we're going to do. They have two methods in teaching it. One is to actually do the math with the fractions, and the second math is to eliminate the fractions. So we'll talk about that. So just real quickly, they say, recall that anytime you add something on one side, as long as you add it on the other, you're keeping the scale balanced. As long as you subtract it on one side and subtract it on the other, you're keeping it balanced. Same with multiplication and division. So looking at this guy over here, we want to get the x by himself, right? Who is on the same side of that equation that we want to get rid of?
1/2.
The positive 1/2, right? So we want him by himself, and we want to move this positive 1/2 to the other side. How do you move it over? You change it to a subtraction problem. So we're going to subtract 1/2 over, and if we do it to the left, we do it to the right. This gets kind of messy. I don't know a good way to do it. Sometimes people put a line, like where the equals is. All right, help me out over here. What's going to be the only thing left on the left side? X, right? Because what's 1/2 take a half? 0. And then over here, I'm going to write it horizontally. You might not, but I am. I'm going to write this as negative 1/2 minus 1/2.
I changed it plus negative 1/2, right? Because you do negative 1/2 plus negative 1/2.
Oh, you're saying that what our next move is. Absolutely. So she's realizing, hey, in order to do subtraction, we change it to addition. So this is just x equals negative 1/2 plus a negative 1/2, right? The first fraction stays the same. The subtraction changes to a plus, and the second number changes to its opposite. If you don't need to do that and you know what negative 1 minus 1 is, that's fine. This is where we celebrate the small things. What do we need in order to add or subtract fractions? What do we have? A common denominator. So what is negative 1 plus negative 1? Negative 2, right? When they have the same sign, you add them and give them the sign they share. All over what? 2. So what is the answer to this equation? Negative 1. Look at you guys. You are doing not only fractional math, but you're doing fractional equations. That's crazy. Okay?
I like these.
You like the algebra?
Yes.
You'll probably like Math 112 then, because that's what a lot of algebra. So what we're doing is we're just moving stuff over using the opposite, okay? So since this was added, we just subtracted over, and at this point you just do the math like we did in 4.4 or whatever. Let's look over here. We want the z by himself. Who's in our way? The negative 4/15. So what's the opposite of subtracting 4/15? Adding 4/15. So we're going to add 4/15, but if we add it to the left, we got to make sure we add it to the right. And again, you might like keep this just kind of to keep everything straight. So Stacy would struggle with this one because her calculator doesn't have a Z on it, right? Or not calculator, her computer doesn't have a Z. So what we have over here on the left, the Z is the only thing because a negative 4/15 plus a positive 4/15 cancels out to 0. That's the whole reason why we did that. Equals over here again, I'm writing it horizontally, 3/15 plus 4/15.
Oh, okay. Never mind.
Is that okay?
No, never mind.
What we want is a common denominator. What do we have? Common denominator. So what's 3 plus 4? 7. So Z is 7/15. Does 7/15 reduce any? No, but you have to ask yourself that. And that's what's hard about this. You get excited that you did the math. You're like, woohoo! And then you're like, crap, it simplifies, So don't forget to always check to see if it reduces. Okay? So you move it over doing the opposite operation and then do the math as we learned previously in the chapter. So 7/15 is our answer there. All right. So they try to scare you because they haven't moved on the other side. It doesn't matter. We don't care where the variable is. He's right here. And so what we want to do is we want to get rid of this negative 5/6. How do you get rid of a subtracted 5/6? Add. It's always the opposite. What's the opposite of subtraction? Addition. So if I add 5/6 on the right, I need to add 5/6 to the left. On the right, yeah, I already heard what we need to do. On the right, we have the x, right? And the negative 5, 6 and the positive 5, 6 cancel out. But on the left, I'm going to write it horizontally. We have a negative 3/8 plus 5, 6. And I already heard, what do we need? A common denominator. So we need an LCD, guys. Start with 8. Can 6 go into 8 evenly without a remainder? No. What's 8 times 2? 16. Can 6 go into 16 evenly without a remainder? Nope. If it was 4, it could, right? 8 times 3 is 24. Can 6 go into 24 evenly without a remainder? Yes. So our LCD is going to be a 24. And guys, this equals x kind of just hangs out the whole time, all right? So how do we change to equivalent fractions? We just said whatever we did to the bottom to get to that new denominator 24, we just have to make sure we do to the top. So what did we multiply 8 by to get to that 24? A 3. So we're going to multiply the top by a 3. So we're going to get negative 9 24ths. Is that okay? What do we multiply 6 by to get to 24? 4. So we're going to multiply 5 by 4. And you have 20 24ths. And at this point, it's our chapter 2 math. What do you do when you add opposite signs? You're really doing what? Subtracting. So what's 20 take away 9? 11. Will it be a positive 11 or will it be a negative 11? Positive, right? So this is just 11 24ths equals x. If you want to flip-flop it and write x equals 11 24ths, that's fine. Because the equal sign, like, you can go back and forth, back and forth. So what we did was our first move was it was subtracted. So to undo subtraction, you add it over. So we were left with negative 3/8 plus 5, 6. We said we needed an LCD. We came up with 24 as our LCD. I never wrote it. So we multiplied 8 by 3 to get to 24. So we multiplied negative 3 by that. And that's where the negative 9 came from. We multiplied 6 by 4 to get to 24, so we had to make sure we multiplied the 5 by that. And at this point, it's just, like, don't even worry about the denominator, right? You just do chapter 2. When you add opposites, you're really subtracting. So 20 minus 9 was 11, and 20 was the bigger. Oh, gosh, look at this stuff. Woo! Let's see if we can do it. We can do it. Okay. So first thing, before we start moving things to the left and right, we want to get things simplified and collect like terms on one side. So do you guys notice that we have an 8x minus 7x? We can combine that. What's 8x minus 7x? 1x or just x, right? So this is just x minus 3/5 equals 11/15. So basically they just made us do one step before we made it look like what everyone else looked like, okay? So we combine like terms. 8x minus 7x is just an x. Now we have our variable in one spot and we want to solve him. So who's in our way? That negative 3/5. How are we going to move that negative 3/5 over? By adding him, right? What's the opposite of subtracting 3/5? We're going to add him over. Why do we do that? Because over here, a negative plus a positive of the same number just cancel each other out. And that's what we want. We just want the x to remain. Over here, I'm going to write it horizontally. We have 11/15 plus 3/5. What do we need in order to add those two fractions, though? LCD, okay? Let's think about what LCD we're going to have. 15, right? Start with that first denominator, 15, and ask yourself, does the 5 go into it? It does. All right? So we're going to have x equals something over 15 plus something over 15. All right? Celebrate the small things in life. What is that first denominator? 15. We didn't change it. So guess what the numerator gets to stay? 11. What did we multiply 5 by to get to 15? 3. So we're going to multiply the top by 3. And what do we get? 9. So our final answer before we simplify is just 11 plus 9, or 20 over 15. But then you ask yourself, can it simplify? And it can. So I'm going to split it up. How does 20 split up? 2 and 10, right? But how does 10 split up? 2 and 5. So do you guys see 20 there? 2 times 10. And then how does 15 split up? Sorry, Bree, I'm like in your way. 3 and 5? So what's going to cancel out there? The 5. If you guys can look at 20 and 15 and know that 5 goes into both of them, that's fine. Go right to that. So this ends up being what, 4/3? Woohoo! So that is the first example, 1 through D. Basically, you have addition or subtraction, and they're each other's opposites, all right? So if you have subtraction, you add it to the other side. If you have addition, you subtract it. So the second half is basically identical. The only difference now is that it's multiplication or division. But remember, they are each other's opposites, okay? So on here, they start with A, a nice easy one. What operation is going on there? Multiplication. How do you undo multiplication? Divide, okay? So what do we want to divide by? Well, we want to get this x by itself, so we need to divide by the thing that's with it, the 9. Does that help us? Yes, because what's 9 over 9 end up doing? Canceling out, right? And it leaves us with just that x. And on the right side, what are we left with? 4 divided by 9. Ask yourselves, does that reduce? Yes. Maybe, right? And so what you could always do is, what's 4 split up as? 2 times 2. What is 9 split up as? 3 times 3. So nothing cancels out, but it doesn't hurt you to go that step and just double check, okay? Yep. All right. Here, what's going on, guys? This is multiplication again. So how do you undo multiplication? Divide. And it's kind of weird, but go divide by 1/3 like that. Divide by 1/3 like that. And we're going to just rewrite that as a division problem, multiplying by the reciprocal, right? So on the left, what is 1/3 over itself? Just 1, and it leaves us with an x. On the right, what's 5 divided by 1/3? It's 5 times 3 over 1. Do you agree with that? Multiply by the reciprocal. Did I skip too many steps there? Is that okay if I go straight to the multiplication? Okay. When you divide by a fraction, you multiply by the flip. So what's 5 technically over right now? 1. So multiply straight across the top. What's 5 times 3? 15. What's 1 times 1? 1. But what's our final answer going to be? 15. What I failed you as a teacher is we're solving for the unknown. We want to know what number, when you take 1/3 of it, do you get 5? 15. What's 1/3 of 15? 5. And so that's what we're doing. We're solving for those unknowns. Over here, guys, C and D are basically identical. They're just making sure you feel comfortable with the signs. What happens when we take a negative divided by a negative? We'll get a positive. So who do we want to divide by?
3/8.
The 3/8. Why did you know that? You're right. Because he's with the x, right? We want to get that x by himself. So we got to get rid of whoever's over there. So divide by negative 3/8 over here. Divide by negative 3/8 over here. On the left, what's any number divided by itself? It cancels out to 1, and you're just left with x. On the right, we have negative 4/5 times the flip, negative 8/3. Does that look okay? So we know a negative times a negative is a positive. Is this going to reduce any? What do we have on the bottom? What are the only factors we have on the bottom? 5 and 3. Do 5 and 3 go into either 4 or 8?
No.
So do we even need to break them down to the 102s that they are? No. If you do it, it doesn't hurt you. You just do it to find out that nothing cancels. So then you just multiply it back all up again, all right? So this ends up just being a negative times a negative is a positive. What's 4 times 8? 32. What's 5 times 3? 15. You got it. That's our final answer. And it's just the same story over and over again, right? Who do you want to get by ourselves? The A. So who's in his way? The negative 8. Right? So we're going to divide this side by negative 8, and we're going to divide this side by negative 8. On the left, the negative 8 over the negative 8 will reduce itself to a 1, so we're left with A. Over here, we have 16/25 times, what's the flip of negative 8? 1 over 8, right? So that's negative 1 over 8. Whenever you have to flip a whole number, that whole number is technically over 1, right? So when you flip it, it's 1 over that number. This will reduce, so I am going to break it down, guys. This is 16, which is 2 4s, but each of those 4s are 2 2s. So this is, and I'm going to put the negative in front, negative 2 times 2 times 2 times 2 times 1. The reason why I'm just putting the negative in front is because I don't want to lose it in there or make it look like a subtraction, right? We know a positive times a negative is a negative, so I put him in front. The 16 is 4 2s. What about 25? What's he break up as? 2 5s. Doesn't really help us. And what's the 8 split up as? 3 2s, right? Guys, if you can look at that and you know 8 goes into 16 2 times, if you want to do that, that's fine, okay? So what do? We can cancel out 3 groups of 2. So what's that leave on top? Negative 1 times 2, no, just negative 1, is that right? No, negative 1 times 2, which is negative 2. And then 5 times 5 is 25, does that look right? Negative 2 over 25. Just look at that, guys. You guys are doing these equations without a single calculator. And pretty easily, might I add. Are there any questions there? All right, so the last page is really short because it's just showing you a second method, all right? Again, I will not force you to do one method over the other. Personally, I like this way because I think it's just reinforcing everything you know about math with fractions, okay? But the second way, if you read it, it says, solve equations with fractions can be tedious. If an equation contains fractions, sometimes it's often helpful to actually multiply both sides of the equation by the LCD, okay? So basically, if you multiply by the LCD, you're able to eliminate the fractions and you're left with something that's easy to solve. So let's look at this one. What's the LCD between 5 and 25? 25. So what it does is it multiplies this by 25 and this by 25.
So basically the top 2 numbers.
Yes. So over here, we're going to have 3 times 5 times 5 times y. Okay? Because I'm going to break it up because I want you to see what cancels out. I don't want you to have these big numbers. And that's all over 5 because we have that 5 there. And over here, you have negative 7 times 5 over 5 times 5. But what's always going to happen is that since the LCD has both denominators in it, the denominators will divide evenly, so you'll be able to cancel out and the denominators disappear, okay? So notice what happens on the left side. What happens? A 5 disappears. So what are you left with on the left-hand side? 15y. Do you guys see that? On the right-hand side, what happens? The 2 5s disappear and you're just left with negative 7. And so the whole thought there is 15y equals negative 7 is easier for you to solve because what's the next step you have to do? Just divide by 15 and then you're done. So if you divide by 15, he disappears and you're left with y equals negative 7/15. So the whole thought is that you didn't really have to do any math with fractions other than the LCD part. What do you guys think?
No, I think I missed
The, oh.
No,
No, you probably didn't. You probably didn't. It just literally take both sides and multiply by the top by your LCD. And since your denominators go into your LCD, your denominators end up disappearing, right? The 5 went into 25 5 times. And so, do you like this way?
It's confusing.
Yeah.
It's confusing.
The other way.
Do you want to just ignore this page?
Yeah.
Please.
If we all agree.
What do you think? Can I show you C? And if you don't want to listen
Yeah,
to me,
show
you can go
us.
la la la.
Yeah, show us that.
All right. So let's look at C. C, what would be the LCD for C?
15.
15. Okay. So we're going to multiply each numerator by 15. But when I multiply by 15, I think it's easier to keep it broken up as 3 times 5. Okay. So really this is 15b, but really it's 3 times 5b over 3. You guys see 15b there? 15b
Yeah.
right there. And it's all over 3. All right, over here, it's going to be the same idea. 3 times 5b over 5. Again, it's my 15b. Do you see that? And then the reason why I'm doing that, because you guys could do 15b. That's easy, and know that 3 goes into 15, 5 goes into 15. But who knows 7 times 15 off the bat, and that how many times 3 goes into it? So it's easier to keep it all broken up. So this will be 7 times 3 times 5. Is that okay? 7 times my 15,
Mhm.
all over 3. And what do you notice about each of those fractions? The numerator has one of the denominators in it, right? When you go through, what's going to happen here?
Right.
We're going to start knocking things out, okay? So 3 disappears and you're left with 5b. 5 disappears and you're left with 3b. 3 disappears and you're left with 7 times 5, or 35. And again, the whole thought is you're left with an equation where,
Divide by 5.
no, don't divide by 5 yet, because what we have to be careful of, this is something that's new, we haven't seen yet, is the b's are not together. Like, we want the b's together. Because the whole idea is you want to get your b's together and then separate. So I want to get this b over here with this b. Since he's added right now, what do I need to do? Subtract him over, okay? So I wouldn't have one like on the test, I don't think. I would have this 2-step equation like this, okay? So what is 5 take away 2? It's 3. So we have 3b. Why did I take away 2?
I don't know.
Yeah. Guys, don't listen to me. We should have stopped a long time ago. No, I'm kidding. I think I was thinking that I knew the answer was 2b. Because when you subtract 3b, what do you get? 2b. So you have 2b over here. This cancels out and you're left with 35.
Okay.
But then what are you going to do, Bree?
Divide.
Divide by 2 at that point. I actually don't think I have one on here like this. This is called a 2-step equation because you had to do 2 steps. You had to move the 3b over first and then divide. On the test, guys, I'm going to only have 1-step equations where you either add or subtract something over or divide or multiply something over. Okay. Did I say yes, Cassandra?
On B,
Mm-hmm.
top, how would you,
The LCD would be 7.
because it doesn't have,
Right? Because everything else is over 1. And you just multiply everything by 7. So you have 7x over 7 minus 7x over 1 equals negative 35. Yep. No, it's not too bad. Right? Because you just multiply everything by 7. And what's this? The 7's cancel out. What's 1x take away 7x? Negative 6x. What's a negative divided by a negative? Positive. It's not too bad. All right, the last one, guys, here is just making sure you feel comfortable combining like terms with fractions. Guess what? It's no different than you've been doing this. How do you add 2 numbers with different fractions? What do you need to get? An LCD. What's going to be the LCD between 2 and 7? 14. So this is over 14 and this is over 14. What did you multiply 2 by to get to 14? 7. So what are we going to multiply the top by? 7. What's n times 7? 7n. What did you multiply 7 by to get to 14? 2. So what do you multiply the top by? 2. So you get 8. We got to write it as one denominator, but what's 7n plus 8? 7n plus 8, right? 7 nachos and $8. What do you have? 7 nachos and $8. You have lots of friends then, right?
Mhm.
Make friends if you have 7 things of nachos. On B, what would be the LCD between 8 and 4? 8. I really feel like we've done this already. Like, I feel like this was like on the last worksheet, don't you? Did we change 8 at all? No. So do we need to change 5C at all? Nope. Did we change 4? Yes. What do we multiply by? 2. So what are we going to multiply the top by?
2C.
Can we combine those numerators?
Yes.
Yeah, because they both have C's. If you have 5 cats and you take away 2 cats, what do you have? Less fur in your house, right? 3. We have 3C over 8. Guys, we did this. I don't even know why this is in this section. We did this in the section where we learned how to add unlike fractions. So